So, that is Ls is equal to your self inductance of each circuit, right. Therefore, Ls is equal to 0.4605 log 2 to the power 1/3 into d upon r dash millihenry per kilometer. This is equation 76, and M is the mutual inductance between the two circuit, that is M is equal to 0.4605 log d3 upon d2 to the power 2/3 millihenry per kilometer. Now, this one we call self, and this is that mutual inductance between the two circuit. If you look at that, if you look at the configuration, so we are calling this is that your what you call the first term, that this term we are calling as a self inductance, right, and this is mutual between the two circuit, right, between the two circuit. This is true because look at the expression d2 upon d3, right. That means here if you look, mutual is because of minus sign, this minus we have taken, Ls minus M, this minus we have taken, that is why it is in this expression it is d3 upon d2 to the power 2/3. So, if you look at the configuration, right, so d2 d3 this has because this is coming because of this your between the two circuit, right, but when it is d out cube root of 2 into d upon r dash, that terminology is coming, it is actually within that, that is your d and r dash, right. That is why this part we are calling as a self, this part we are calling as a self, and this part we are calling as a mutual inductance, right. So, this is well known result for the two couple circuit, right, connected in parallel. GMD method also can be applied to untransposed transmission line, and it is quite it gives quite accurate result, right. Now, we will come to bundle conductors, right. So, in this case that bundle conductors actually that means it is economical to transmit large amount of power over long distances by extra high voltage transmission lines, right. So, and those things are basically constructed with bundle conductors, right. So, bundle conductors configuration may be 2 conductors, right, or maybe 3 conductors, or maybe 4 conductors, right, or even more also, right. So, so many conductors if it is there in parallel, right. So, naturally that it has been I mean for extra EHV transmission lines generally they use bundle conductors such that it increase the self GMD and line inductance is reduced, right, with increase the power capability of the transmission line, because if inductance less, then reactance will be less and the power transmission capability will increase, right. So, some bundle conductors also reduce the corona loss, surge impedance and radio interference, right. So, generally the basically bundle conductors usually comprises 2, 3 or 4 conductors as shown in figure 11, right. Here I am showing 2, 3 or 4, but it may be more also, right. So, if you try to find out what will be the self GMD for all this configuration, for example, if you take this two conductor case, this 2 conductor case. So, for a 2 conductor arrangement, right, ds will be just r dash d to the power half, this is equation 78. Similarly, if you consider this 3 conductors configuration, right, then in that case it will be ds is equal to r dash d square, then to the power ds is equal to r dash d square to the power 1/3. How things will happen, that just I am making it. For example, this is some take any conductor, right. So, suppose this ds is, take any conductor ds is, first you will take its r dash, right, then from here from this conductor take the distance of it, that is in d, and from this conductor again you take the d, right, assuming all the conductors have the same radius r, right. So, and distance also they are same, and to the power 1/3. So, it will be r dash d square to the power 1/3, that is what I am writing for 3 conductors r dash d square 1/3, right. This is for 3 conductor case. Now, for 4 conductor case, right, when you take the 4 conductor case, I mean this one, 4 conductor case, this one, right. So, from any conductor, right, say ds, this is for 4 conductor case, and this diagram ds is equal to, first you will take the self one r dash, then you take the distance from this conductor to here, it will be d, then this conductor to here, it will be d, and then this conductor there, this is d, this is d. So, this distance, diagonal distance will be root 2 d to the power 1 by 4, right. That means, this will be your r dash root 2 d cube to the power 1 by 4, right. So, that is why it is coming that for your conductor 4 conductor case, that is quadruplex, right, r dash root 2 d cube to the power 1 upon 4, where r dash is the fictitious radius of each conductor in the bundle, right. So, that is the that is your what you call that self your what you call, you have to find out that all ds, right, self GMD of this kind of configuration. Now, till now for all this regarding your derivation, whatever possibilities are there. So, we have discussed all the, but so far we have not taken any numericals, right. So, next I will take several numericals to support those derivations, right, and different type of numericals we will take, and just so far theory we have seen all the formula, mathematical development, all the things we have seen. Now, we will consider all these things, or what you call that your numericals, and as many as possible I will show you such that a different type of problem such that it will be helpful for you. So, your objective will be try to understand this, right. So, first take the example 1, right. So, when we take this diagram is a small one, I have taken from a book, right, rather than drawing it. So, this is figure 12 actually, it shows the stranded conductor having 7 identical strands, one central strand, and surrounding this there are 6 conductors, right. So, and each of having radius r, right. So, and if all are of same radius, then it is 1, and around that 6 conductors possible. If it is, if radius are different, then things it cannot be something this kind of configuration, right. So, you have to find out the self geometric mean radius of the conductor and the ratio of ds to overall conductor radius. Finally, comment on the results, right. So, this is the configuration. This configuration little bit I think hope it will be readable to you, but first first let us see that I am trying to make it little bigger, hope that drawing will be all right, right. This is the this is central stand, this number is given 7, right. So, around this there are 6 conductors are there, right. So, here this number is 1, say this is 1, say this is 2, this is 3, this is 4, this is 5, and this is 6. Central one is 7, this is 7, right. So, 1, 2, 3, 4, 5, 6, right. So, first you have to see the distance from the strand 1. So, this is this distance means here no, from here to here, center to center, this is one distance, here to here, here to here, this is distance, and of course, here to here, right. So, and from here to center also, right. So, first what you can see is that 1 to 2, actually this is 1, this is 2. So, D12 is equal to D16, D12 is equal to D16 is equal to D17, right. So, here it R, here to here R, so it is equal to 2R, right. So, this is 1 2 16 and this is central conductor is 7, right. When you will listen this video, see that hopefully everything will be readable to you, right. So, this is central is 7, you can hear my voice, right. So, D12 is equal to D16 is equal to 2R, right. Then D14, this is actually this is 4, this is conductor 1 2 3 4, this is conductor 4. So, D14 is equal to 4r, because from here to here r, this diameter is 2r and again here to here is r. So, altogether d14 is equal to 4r, right. Now, d13 is 1 to 3, right, 1 to 3. So, actually this is your 1, just separately I am trying to draw it. This is another one, this is your 1, this is your 3 and this is your 2, right, and this is your 2. So, this is you have to find out, you have to obtain d13, right. So, 1 to 3. So, it will be this sorry, this is actually all together, right, this is all together. So, I will how to make it, just hold on, I am making it. So, this is 1, this is 1 and this is 1, right, and here to here we want to make it and here to here, right. So, this is here to here, it is your 1 to 2 is 2r, this is 1, this is 2, this is 3, this is actually 2r, right. Similarly, 2 to 3 also 2r and this angle is 30 degree, right. So, here you take this projection that 2r cos 30 plus 2r cos 30, that means 2 into 2r cos 30 total 1 to 3, right. Hold on, I will put it little bit up, right. So, 2 into 2r cos 30, that is 2 into 2r, right, into root 3 by 2, 2 cancel. So, it will be 2 root 3 r. So, d13 will be your 2 root 3 r, right. So, so this angle is 30 degree, from the symmetry you can make it, this angle is 30 degree, right. So, that means that is why d13, similarly for d15, 1 3 and 1 5 same distance, 1 to 5 same distance. So, this is d13 is equal to your 2 root 3 r is equal to d15, right. Similarly, if you, this is for when you are taking conductor 1, if you take conductor 2, then meaning will same, that d24 will be is equal to d26. If you take conductor this one, d35 is equal to your d31, this way the things will be there. That means, you have to consider every conductor separately, right. Therefore, you have because you have to obtain your self GMD, right. So, in that case what will happen, first thing is, look how we will make it. First thing is that you have to this thing, you have to see that there are 7 conductors, right, and you want to find out self GMD, that means it is n square. So, 49 1 upon, that means you have to take 49th root, right. So, such that 49 possibilities are here. So, how? Now, first that there are 7 conductors, if you take that fictitious radius of each one r dash. So, including central one 7 conductors are there. So, it should be r dash to the power 7 first, right. Next, I am making d12 square, it has to be repeated 6 times, because look I have written d12 square, I will explain each one, then d13 square into d14 into d17 to the power 6, right. That means, d12, if you take this diagram, d12 is equal to d16, twice it is coming. Similarly, if you consider this one, d21 is equal to d23. Similarly, if you consider this 3 1, d34 is equal to your what you call d32. This way you have to consider each thing. So, for every conductor you will consider that d12 is equal to d16, distance remains same. Similarly, if you consider this conductor also, then you have to take this distance and this distance. If you consider this one, so every time 2 or twice it is coming, and all d12, d16, d32 all distance are same. So, for each conductor this is the distance repeated twice, because one is here d12 and d16, they are same, d12 is equal to d16. That is why here it is made it d12 square, but you have 6 conductors surrounding the central conductor, you have the 6 conductors, that is you have the 6 conductors, right, surrounding the central conductors, you have the 6 conductors. That is why d12 square, but power should be to the power 6, because each conductor if you consider 2 distances are same, that is why written d12 square, rather than complicating the thing d12 into d16 into d23 into d34 like this. So, simply we have written they all are same. So, d12 square. Similarly, if you consider 1 3, then d13 square coming, because 1 to 3 1 to 5 same distance. If you take now 2 to 4 2 to 6 same distance, right. If you take 3 to 5 3 to 1 same distance. So, this way twice it is coming and 6 times, because surrounding conductors are 6 times coming, that is why d13 square again to the power 6, whole I have written all to the power 6 because all are coming 6 times. Next d14 means from here to here. Similarly 2 to 5, similarly your 3 to 6, this way it is coming only once. d14 there is no other similar distance here, 1 4 2 5 3 6, right. Then your 4 1, this way it is coming 6 times, that is why into d14, then to the power 6. Then d17 means from this conductor to the your what you call this conductor, your 1 to 7, that center of the central stand, right. So, 1 7 2 7 3 7 4 7 5 7 6 7 all are same. So, into d17 to the power 6, right. That means d12 square repeated 6 times, then same distance, d13 also similarly 6 times, that is square 6 times, then d14 once, d17 once 6 times, into your d2r, right. d2r means this is the central conductor now you consider, because this is left out. Central conductor, that r dash you have considered for everyone. Now, from central conductor also you have to consider this distance. So, from here to here 2r, 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 6 times. That is why into 2r to the power 6. So, total to the power 149. Now, for how we will check it, for that inside whatever will be there, all together power if you add, it has to be 49. If you say this is not matching, that means your computation is somewhere wrong, right. For example, if you take this power, this is 7, if you take this 2, 6 into 2 12, just add 12 plus 2 into 6 12, plus here power is 1 means 6, right, and here also 1 means 6, and here also 2r to the power 6, right, then plus 6. If you add 12 plus 7 19 and 2 12 your 31, then 6 6 6, that 18. So, total is 49 and power is 1 upon 49. So, that means your things are correct, right. Otherwise, so you have to assume somewhere calculation something had gone wrong. You understood, or I hope you have understood, right. So, if although looks like things simple, but calculation possibility that your what you call that there is a possibility of calculation error. So, this way you have to understand that how many possibilities are there, and I have written 1 upon n square because 7 conductors are there, and all this power just add roughly. If power is different and this is different, the dimension will not match, because ultimately ds, suppose it is meter, it has to be meter. So, in terms of power those things has to match, right. So, that now I am writing for you that r dash is the fictitious radius of each conductor. It is raised to the 7th power to account for 7 stand, that is why 7 stands are there. Then I explained the term d12 square, d13 square, d14 and d17 represent the product of distances from the outside stand to all other stand. This product is raised to 6th power to account for the 6th outside stand. This one also I explained that how I took, right. Then the term 2r6 also from the central stand, I told you 6 times it will come, is the product of the distances from the central stand to every outside stand. This write up I have given and I have explained also how to get it, right. So, hold on. So, now if you substitute, I mean if you substitute all this what you call, just now I showed all these distances that d12, d1 your d14 whatever we got, all these values you substitute here, right. If you substitute and calculate, here I did not bring those calculations because then it will kill more time. With this you can do as an exercise, right. After substituting all this, right, all these values you substitute, then what will happen, that you will get that ds is equal to 2.177 r. This is the final answer will come. This you do please of your own, right. So, the overall conductor radius is 3r, because from here this is 6 strands. So, it is from here to here r, right. If you take overall this thing strand, this is 2r, this is 2r, this is 2r, so 6r. So, radius is 6r by 2, so 3r. Therefore, the overall conductor radius is 3r. I have written here 3r. Therefore, the ratio to overall conductor radius is 2.177 r divided by 3r is equal to 0.7257, right. As the number of that, I have made one thing, that comment on the result, right. So, in the new beginning, therefore, as the number of strand increases, this ratio actually approaches 0.7788, right, which is that of a solid conductor. That is the comment, right. So, this is example 1, hope you have understood, right. Next is example 2. Now, so first I am reading this problem, right, then we will give the diagram. So, a 3 phase 50 Hz 30 kilometer long line has 4 number 4 by 0, this is some kind of conductor specification, wires in bracket 1.5 centimeter diameter, right, spaced horizontally 2 meter apart in a plane. The wires are carrying currents IA, IB, IC, and the fourth wire is a neutral, current is 0, fourth wire is a neutral, carries 0 current, right. The phase currents are IA is equal to minus 30 plus J 24 ampere, IB is equal to minus 20 plus J 26 ampere, IC is equal to 50 minus J 50 ampere. One thing is there, in the problem the neutral current may not be mentioned, but if you add IA plus IB plus IC, if it becomes 0 means current through the neutral is 0, although it is mentioned in the this numerical, right. Next, the given that line is untransposed, the line is untransposed. So, you have to find out find the flux linkages of the neutral wire, find the voltage induced in the neutral wire, and find the voltage drop in each of the 3 phase wires, right. So, first is the diagram, it is on the horizontal plane. So, 3 phases A, B, C. So, IA, IB, IC, this current carrying conductor, and this is the neutral, and distance between these conductors are phase and neutral, everything remain 2 meter, 2 meter, 2 meter, right. So, this is the arrangement of the conductors. Now, first this calculation is very simple, D A to N 2 plus 2 plus 2, so 6 meter, D B N B to N 2 plus 2, so 4 meter, and D C N C to N is 2 meter, and radius is diameter is given 1.5 centimeter. So, radius is r is equal to 1.5 by 2 centimeter is equal to 0.0075 meter, right. This is this thing. So, generally in transmission line, that between the 2 phases distance is quite large compared to the radius. So, d minus r is equal to approximately equal to d, because r is too small, right. So, now flux linkages of neutral wire N, so many theories we have told from the earlier discussed also. So, directly you can write that flux linkage of neutral lambda N is equal to 0.4605, then your objective is to find a flux linkage with that neutral conductor. So, IA is equal to lambda N is equal to 0.460 IA log 1 upon dN, A to N distance, plus IB log 1 upon dBn plus IC log 1 upon dCn milli Weber turns per kilometer. It is milli, right, milli Weber turns per kilometer, right. Now, in this expression you substitute DAN, DBN and DCN, all have been given here, you substitute, right. If you substitute, you will get lambda N is equal to 0.4605, in bracket you write down IA log 1 upon 6 plus IB log 1 upon 4 plus IC log half milli 1 upon 2 milli Weber turns per kilometer, right. Now, after this one log 1 upon 6, log 1 upon 4, log 1 upon 2, whatever value comes you put, it will get, you will get lambda n is equal to minus 0.4605 bracket 0.778 Ia plus 0.602 Ib plus 0.301 IC milliweber turn per kilometer, right. Now, after this you substitute the values of Ia, Ib and Ic. This Ia, Ib, Ic, all these values are given. So, what you do? You substitute here Ia, Ib, Ic. If you substitute Ia, Ib, Ic here, I have written one step here, skipping this one. Final one is lambda n is equal to 0.4605, in bracket it will be 20.33 minus j 19.274 milliweber turns per kilometer, right. Now, so flux linkages with neutral air, this is the expression, is complex one, right. Now, second part is you have to find out the this is the flux linkage. Part B is the voltage induced in the neutral air. If Vn is equal to j omega into lambda n, right, into 30, because length of the air is given 30 kilometer. So, j omega lambda n into 30, right. So, it is j 2 pi, assuming that it is written there 50 Hertz system, it is written there a 3 phase 50 Hertz 30 kilometer long, because here we are multiplying with 30 such that we want in volt, because it is given per kilometer, that is why multiply by 30, j omega lambda n into 30 is equal to j 2 pi, frequency is 50 Hertz into 30 into 0.4605, it is milliweber. So, milli we are making 10 to the power minus 3 into this thing 20.33 minus j 19.234, such that it will be in volt, right. So, if you multiply, then Vn is equal to 121.58 angle minus 43.5 degree volts, right. So, this is the voltage induced on the neutral wire, right. Now, part C, from equation 60, the flux linkage of the conductor A, I have kept A under quotation, right, inverted comma, that is, right. So, from equation 60, the flux linkage of the conductor A, we write lambda A is equal to 0.4605 Ia log 1 upon r dash, this is for conductor A, right, that is why we are writing Ia log 1 upon r dash plus Ib log 1 upon d plus Ic log 1 upon 2d, right. So, that means your, instead of writing directly 2 meter, that from A to, from first one self one Ia log 1 upon r, then Ib means A to B distance is d, that is log 1 upon d, then your A to C, just hold on, then your d is 2 meter. So, instead of making that A to B Ib, that is your log 1 upon d, and Ic to this thing, it is log 1 upon 2d, because this is 2d, right. So, milliweber turns per kilometer, right. Now, it is neutral current is 0. So, Ia plus Ib plus Ic is equal to your 0, that means Ic is equal to minus Ia plus Ib, right. Therefore, what you will do, you can do it, right, from this one your what you call that Ic is equal to, you substitute minus Ia plus Ib in this expression, you substitute Ic here only, I am not showing, I am putting, you substitute and then simplify, right. If you do so, you will get lambda is equal to 0.4605 Ia log 1 upon r dash plus Ib log 1 upon d plus Ia log 2d plus Ib log 2d, right. Now, if you further simplify, lambda A will be 0.4605 Ia log 2d upon r dash plus Ib log 2 milliweber turns per kilometer, right. Similarly, you compute lambda B also 0.460 Ia log 1 upon d for the case of B. So, plus Ib log 1 upon r dash plus Ic log 1 upon d milliweber turns per kilometer, right. Here also follow the same philosophy, right. Here also you eliminate your what you call Ic, right. In this case also you put Ic is equal to minus Ia plus Ib here. If you do so, you will get here, right. After simplification, you will get here lambda B is equal to 0.4605 Ib log d upon r dash milliweber turns per kilometer. Similarly, lambda c also you make 0.4605 I a log 1 upon 2 d, right, because c to a distance is 2 d, right, then plus I b log 1 upon d plus I c log 1 upon r dash, because for lambda c I c log milliweber turns per kilometer. Here also follow the same thing, that I c is equal to minus I a plus I b, you substitute in this expression here only, then simplify, right. In this case in this case, in the case of lambda c, that your I a log this I b log 1 up log 2 d plus I c log 2 d plus I b log 1 upon d. So, here in this case what we have done, we have eliminated actually your I b I c, we have eliminated I a actually, right. So, in this case you eliminate your what you call that I a part and just simplify. So, in this case not like I c is equal to minus I a plus I b, just simplify. So, whatever will come I a, I b, I c, so I b and I c is there, I a actually is eliminated. So, in that case lambda c will be 0.460 I b log 2 plus I c log 2 d upon r dash milliweber turns per kilometer, right. So, in this case whatever I b, I c is there, so just eliminate, substitute I a is equal to minus I b plus I c, then you do this, right. So, this is lambda a, lambda b, lambda c. Now, voltage induced in that voltage induced lambda V a will be 0.4605605 into your j omega, right, into milliweber is there, that is why 10 to the power minus 3 and 30 kilometer length is there into 30, and in bracket this expression for delta V a, right. So, I a log 2 d upon r dash plus I b log 2, right. So, where is our expression for lambda a, right, this is expression for lambda a, I a log 2 d upon r dash plus I b log 2, right. So, I a, I b, then here you substitute the current I a and I b, I a is equal to this much, I b is equal to this much, you substitute d is equal to 2 meter, right, and calculate. So, you will get delta V a is equal to 514.4 angle 230 degree point 2 volts, that means in phase A this is the induced voltage, right. So, whenever it is written B C, so accordingly I have eliminated, right. Similarly, if you calculate for phase B and phase C, right, phase B and phase C, delta V B will be 360.8 angle 217.56, this you please calculate of your own, but this answers hopefully it is correct, right, and delta V C is 827.7 angle 45.4 degree volts. So, my suggestion is, when you will listen to this, if you have any problem or anything, you just mail to me, right, and if you have any doubt or any sort of complication arises, you just mail to me, definitely we will try to reply you quickly.